Yes, good evening. Hello, can you hear me? Yes, thank you so much. Welcome back again to our engineering intermediate sessions. We are still proceeding with Python advanced topics. And like we had said, we are trying to understand Python from its basic fundamentals to production ready Python. So last week we had already started, but I think due to some reasons, I was not able to attend yesterday's session. So my apologies. Uh, Sorry. Yes. So last week we started with we were actually exploring the 5 fundamental Python areas. So I could open my notebook. I don't know whether you have it. I think it would be better if I share it on the chat as well. This class in the chat. So now we can move together. So we had said that we are discussing 5 topics, that is data structures. Uh, Let me just, I've shared the notebook on the chat. So if you check on the chat, you'll find the notebook. So like we had said, if you've done intermediate level Python, that is you are familiar with variables. You can work with various types of data that we call data types, looping, decision functions, and able to build even a simple application in Python. Now, when you want to advance to more interesting areas, I don't want to repeat it much, but we said that data structure is very important because it is actually a way for you to organize data efficiently within your application or your AI projects. So data structure is very, very key. And as you're doing data structures, it's good for you to keep in mind about the time complexity and the space complexity, where we say that the time complexity refers to the duration that it takes for your program to run. And then the space complexity talks about uh, the memory that. Then from there, we really took our time, I think, and we talked about object-oriented programming. I don't want to repeat much about it because we've done quite a lot on it, but it's good for me to mention that OP focuses on objects. And we say that objects is anything that has states and behaviors. So if you want to build these objects, we said you need a class. Therefore, we defined that a class is a blueprint that we use to build objects. So therefore, inside a class, we'll have to define the states. Sometimes we call it properties, and then behaviors for these objects that we are going to create. I think we demonstrated that with a lot of examples. For example, the car example. If you're building a car as an object, then these are the properties that will make a car. And then this is actually the behavior that a car can do. So behavior talks about functionalities that can be done using an object. So yes, one of our students defined for us that an object read that car, we can now have many instances. For example, you can have an instance of Toyota, we can have an instance of Subaru, another instance of Ford. But all these are cars, so they are modeled as car. So they have one blueprint. An object is an instance of a class. That is also very, very, very true. So we did quite a number of examples in whether I'm audible. Can you hear me? Kindly, am I audible? So yes, maybe you can mention on the chat. I hope you're able to hear me. Yes, yes. Thank you, Alfred. Breaking. How about now? I hope now it's okay. So I've tried to. Perfect. Thank you there. Yes, I was trying to just do a quick recap of areas that we've been talking about since we started. So that was a lot. OOP. OOP is very, very key. Always remember if you're doing OOP, then you're focusing on objects in such a way that this object must have properties and they must do something that we call a behavior or actions. So we did even more realistic example. I was trying to show you how OOP is really important, especially if you're building real application that like the ones we are going to focus on. Bank account is an object in such a way that for a bank account, you need to define the owner, the balance. This is just some few properties. You can even define PIN, you can define branch, you can define location, and so on and so forth. And within a bank account, there are some actions you can do, like you can deposit some cash to your account. So that is a behavior, it's an action. You can check your balance, you can do some bank transfer. So all those are actions. And what we saw that is that with one blueprint of a bank account, as we're seeing here, we can now build several instances of bank account. And this was a practical example that was showcasing the real use case of object-oriented programming. So if you think about OP, we are thinking in such a way that every bank account that we create is, and that is the idea of OOP. So OOP is everything is treated as an object, okay? So within your bank account, there are things you can do with your bank account. You can go take your account, do deposit, and the rest. So that was the practical example. Another one was mobile wallet, where you can define the owner, the balance, you can add money to your wallet, spend some cash, and so on and so forth. So I hope it's making sense. So that is the whole idea. Let's say a student, if you're building a student information system, then we have several properties that makes a student, and then we have some actions that a student can do within the application. If you're building an hospital management system, it's the same. A patient has some properties like the ward number, the doctor that he was assigned to, diagnosis, and then there are things patient can do. Patient can pay, patient can what can he do? Can check the balance and so on and so forth. So object-oriented programming, you think of everything as objects. I hope that one made sense. And to make OOP even more interesting, as we saw, we have these principles of object-oriented programming. We didn't have time to do them in depth, but it's good I mentioned, then you can also do some research. A practical example of object-oriented programming principle is inheritance, where you allow a class to use another properties and behavior. This is very, very useful, especially if you're building mobile application, if you're building web applications. Most of the time, you're going to inherit some classes. We talked about encapsulation, restrict access to some information, polymorphism, and abstraction. So we just to demonstrate in such a way that if I have a bank account as a parent class that I was also calling a super class, I can have a savings account inheriting all the properties and behavior of a bank account. Remember, savings account is an account, it's still a bank account. So therefore, with a savings account, you are allowed to deposit, you're allowed to withdraw. But apart from that, you can also generate some interest with a savings account. So that is a good practical example of inheritance, where we have one class inheriting properties and behaviors of another class, especially if you're building Android applications. Then you're going to see a lot on how inheritance works. For this session, we are going to use a library called LangChain. And I gave you some assignment to go research about it, but you're going to realize that with LangChain, it will actually help us build these AI agents. Okay, remember, agents are AI applications that can do some process autonomously on their own. Therefore, if you're building them, we'll have to build the best tools that these agents have. Then from that agent, we can now build several applications doing their own stuff. We can have agents to search website. We can have agents to do data entry and so on and so forth. So OOP, because we are going to use it a lot as well in our AI projects. So that's why I've really taken a lot of time with object-oriented programming. So please, if you find time, kindly go through the object-oriented programming principles. I don't know whether I can give you as a research assignment to submit. And I'm sure you're going to learn a lot from these principles. And you're going to see how these principles are used in different applications. So remember, Python is not only used for AI, it's also used for cybersecurity. It's also used for data analysis, can be used to build web application. So with these principles, we are now able to do a lot with this Python programming. So for today, and like we had started, I am going to start on the third topic, which is decorators. So right now we are remaining with decorators, very important. Then we are also going to talk about generators. Then finally we'll do Pydantic. And with that one, I can say that we've actually done some advanced level Python. So the remaining thing is now for you to do practices in websites like LeetCode, like I had shared with you earlier, and then you're ready to be a Python expert. So remember, you can even be a Python developer. You understand all these principles we are talking about. So after I've done Pydantic, the remaining thing is now for you to practice. And remember, as we say, practice makes perfect. And their website available for you to practice your knowledge in Python. A good one that I highly recommend is LeetCode. But for more advanced practicals, there's also another one we call HackerRank. Especially if you are trying to do interviews with these big corporations like Amazon, most of their Python interview questions are more or less generated from HackerRank or LeetCode. So this is now your challenge. From here, it's now up to you to now proceed with now practices. And with time, let's say you give it like a month time frame, you should be an expert in this programming language. So let me share these links if you don't have them, and then we proceed with decorators. So as I'm sharing, I don't know whether someone can research for us what is a decorator. I can remember we had introduced it. But we can do it again. It's a new week, so we can still introduce it again. So I've shared with you the tool website that I highly recommend for your practices in Python. Remember, Python has a lot of opportunities out there, a lot. So by you understanding it in depth, it's very, very much applicable. So let's go to decorators. And if you could remember, not generators, decorators. If you could remember, we had said that a decorator another function. It can be defined differently with different sources that you're getting, but the idea is you have a function that tries to modify another function. And we demonstrated a good example here. You have a function, you're calling this function, so you're calling this function called give gift. So you want to present someone a gift. Remember, we are actually from the festive season, so you want to give someone a gift. If it will be okay if you just present the gift like that one. Get you a toy car, receive this iPhone. I don't know. So you're giving someone a gift, but it will be even much better in most cases if you decorate that gift to look better. So this is a function called give gift. So for you to understand decorators, you need to understand functions, especially what we discussed about function definition and function calling a function. And remember, we had said that for you to create a function, you start with the keyword def, you give it the name, and then you write the functionalities of that function here. So if you want to call this function to work, you just call it here, and it works. So this is something we have already done. But now, as we are now advancing, we are saying that now imagine modifying this function without touching its content inside here. Without us touching its content here, we are able to do a decoration. And that is what we are learning today, called decorators. So I don't know whether someone can research. I don't know whether you found a different definition from that one, but a decorator is a function that tries to modify another function. So how do we modify this function? So this function, as we are building a decorator, we can refer to it as a function like that one. Okay? And then we can now take this function and modify it somewhere else. And that's what we did here. So remember, we have built another function called gift wrap. So remember, we are going to present a gift. Therefore, this function that I'm calling function here will be passed here so that we can wrap that gift. So I have this function with decorators. Normally, you have another function inside it to do the operation. So for you to do a gift wrap, you have to now create another function called wrapper, and then maybe we can implement this one, and then we can call this function in between where we are wrapping the gift and where we are adding the bow. So that is where we can call our function. And now, if I want to modify this function with a decorator, what I can do, I can call this function here. And for me to call that function here, we normally use @ symbol. So that is now the symbol of decoration. So it means that this function give gift, we are now decorating it with another function called gift. I think we've called it gift underscore wrap. So that is now the concept of decorator. So now if you run this function with the decorator, let me run it here. We are modifying its content without touching what it has inside. I don't know whether it's making sense up to there. I don't know whether is it really making sense up to there. When we talk about decorators, so we have a function that we can decorate here. So if you build applications like Flask or Django, most of the time you are going to meet these decorators a lot. Yeah, so that is the idea. That is the simplest form of a decorator. Remember, if you have a question, you can always ask. So a decorator is a function that has the ability to modify another function. So for example, this function called gift wrap, it has an ability to modify our function give gift in such a way that instead of just executing this command, we can also add more information to that function. So that is what we call a decorator. So let's try another use case. If there is no question, I hope there's a question. If you have a question, please feel free to have your question on the chat. Another example of decorator is this one here. Another good example of decorator is, sorry, I think I'm lost. Yes, so yes, you're here. So this is another good example of a decorator. So if you're having a heavy task, this is a very common tool, especially if you're implementing very heavy task application. We need to know how long it took, or we can even do some logs. So remember, we're talking about logs. Logs refers to information about a certain service. Like if you have a server, it's able to generate server logs. So this is a very practical example. Let me remove this decorator. It's also best to demonstrate without it first. So if I remove this decorator, this is an heavy task. It will take time. The work is done, which is okay. I've done the work. But remember, in some cases, we'll have to know how long that task will take so that now we can start rendering information to the user. Let's say, for example, you have built an AI agent to send email. Before you present to the user that the email has been sent, we need to know that how long it would take so that now we present to you the work has been done. So we can actually do a decoration to determine how long a task is performed. So this one, I added here deliberately to just take 1 second, okay? So I just added it here to take 1 second, just to pretend we are doing a lot of work. Because yeah, just printing work done is very simple, but can even give it a timer, like I can say, 2. So it will take time for you to see the name work done. Can you see? It's taking 2 seconds. So how do you know that this work has taken 2 seconds? I'm trying to demonstrate that this is a heavy task. It can take a lot of time. Yeah, for example, you have an AI to go through your resume, write for you a recommendation. So normally they take time. So you have to know the duration. So for us to do that one, we have created a function called time decorator, just like we had created the other one. This time decorator, it has a capability of modifying a function. And as always, so this is a function that is going to modify that other function that we have passed here, okay? So for me to know the duration, I'll have to know the start time. So I'll get the start time from the time. That's why I've imported time. So I'll get the start time, and then the function will now execute that. I want you to imagine that function is the heavy task that is being done. Then when the function stop has finished its operation, we are going to calculate the end time. So for me to get the total time taken, I should subtract end time from start time. Okay, I can present it as seconds, and then I return. So if I pass this function here, it will actually calculate for me how long this heavy task has taken. So remember, this is our function. This is our function. As this function is executing here, we have the start time, and we also have the end time, and we are printing that one. So instead of just printing work done, that is the concept of decorator. Instead of just printing work done, we can decorate it here. And all the time, if you want the decorator function, I think I call it time decorator. This one here, yes, that one. That has a capability of modifying this function by adding the time taken. So if you run this one here, it is telling us that this heavy task has taken 2 seconds for it to complete the work. And that is very, very useful, especially if you're building complex application. So you can build an application that has to go to the database, fetch all the information, write a report. So remember, that is a very heavy task. So as the heavy task is being implemented, we can even have a progress bar. And then now the decorator can tell us when the heavy task is done. And then now we render the result back to the user. And that is what we call a decorator. So if you work with ChatGPT, that is the case. As you give it a prompt, normally it takes time to interpret your prompt and then now render the result. So while it's processing your prompt, there is something like, what is it called? It's not a spinner, it's called a progress bar. Yes, a progress bar loading until now you've completed the work, and then we can present back the result. And that can be done best using a decorator. Any question? So in terms of reality, I have given you 2 examples. I don't want to explain the codes because we are still going to redo them during our AI projects. But as these engineers are saying, most engineers are saying, if you want to work with an AI model, sorry, yes, sorry for that one. If you're building this AI application, we use something we call APIs. So we're going to talk about APIs. And with an API, it allows us to use these large language models like OpenAI or Gemini or Cloud. Okay, so with an API, you can use a large language model. As an AI engineer, you'll have to write a decorator to automatically retry if it failed. so that the user doesn't see that error. So that is the whole idea. You can actually tell a language model to go and fetch information from database of your company, and that operation fails. With a decorator, we can retry that operation until it is successful without the user knowing that there is an instant where it failed, okay? So there is a function called retry. Retry that logic. Anytime it fails, retry. So let's say you've called an open AI API, and then you've passed your prompt here, okay? Yeah, for example, this is just a simulation. I hope it's a simulation. It's not a real world, how we call OpenAI application, because you're going to use LangChain. But let's say fail. If it fails, this decorator will allow it to retry until we have a successful operation. So that is one idea where decorators are used to retry any failed attempts. Another one is memory. I was even researching for it right now. I hope you've noticed that these large language models have a memory. They can remember your previous conversations with it. Because the previous conversation, unless you erase them, we can do something called caching in such a way that we have a decorator that can cache information and gives the AI an ability to remember your previous operation. Right now, if I open my ChatGPT or if I open my Gemini Pro, it remembers what I've been asking it all the time. I've been asking it about AI, I've been asking it about data analysis and so on and so forth. So it knows who I am because of the idea of caching. So caching can be done using decorators because you just have a function called memorize. You pass a function. Inside this function, you have the property of caching. Okay, and for all the conversation we have, all that result will be stored in the cache library. So anytime you're doing expensive data processing, you don't have to reduce some functionality because it can memorize the previous conversation. Yeah, like for example, you've provided an AI with documents, and you've told the model, the first thing I want you to do is to extract all the information from this document. Then it would memorize that one. From there, I want you to write a detailed report about what you got. So it's able to memorize information using the decorators that you're talking about. Because with this decorator, it is now able to modify the responses that you're getting from this function here. And that is the big idea about decorators. So you can use decorators for time, you can use it for retrying, you can use it for memory. Later, as we're using these large language models, some are paid. A good example of paid models are OpenAI. So payments are done based on tokens. So as you are prompting this AI, we need to keep in track about the tokens that you're using. And that can also be done using decorators. So I think that should be it with decorators, unless there is a question. So what you should always remember, anytime you see this @ symbol in Python, then just know that that is a decorator. And its main functionality is to modify the existing function here. Okay. Anyone with a question with decorators? Before we now proceed to anyone with a question? Edward, any question up to there? Hello? I think I didn't hear you. And, yeah, repeat on the art symbol. Yes, now I've seen it on the text. So this art symbol, it represents a decorator, this art symbol. And like we've defined is that a decorator, it's a function that is able to modify another function. So how is it able to modify another function? By decorating it. So you can build a function here called memorize. And for you to decorate this memorize to another function, we did now the art symbol. This art symbol is very, very, you're going to see it a lot in the codes that you're going to write. We'll be decorating some function with different functionalities. So the art symbol, based on your question, Alfred, is to call the decorator here. The art symbol is to call the decorator. So if you don't have it, if I remove it like that, then this function can only do what it has. It's only implementing what it has. But if I call the art symbol, then so just a minute. Yeah, so if I answered you, Alfred, if I've answered you there. Okay, thank you there. So let's proceed to generators. So let's proceed to generators. Let's go to generators. So generators is also very applicable, especially to our AI projects, because a generator, it can yield result. So remember, a normal function just to execute task, remember here. I hope you can see here. But now with the generator, you are able to yield results. I don't know how to explain it better, but let's say you have a vending machine. So a vending machine has to yield its output at a time. So you yield information at a time, okay? So for example, if you go to the vending machine, the first item to be yielded will be the first snack, then the second one, then the third one, in a certain order, okay? So if I call this generator vending machine, it is able to yield information at a time, like this one here, snack one, snack two, then I can even try and print the third one, that one, third one. Now it's yielding. So instead of returning information, it is yielding information. And that is what we call a generator. Maybe someone can research for us what is a generator so that now we compare with what we are trying to understand here. So it yields information. So let me then show you a good example of where we can work with a generator. Let's say you want to generate numbers. Generators can generate numbers on your computer without crashing because they are not stored somewhere. They are yielded from the memory. In this a good example here. So this is a function to count number up to the maximum. So if you say you want to count numbers up to 10, you can count numbers up to 20. So that's a function to do that one. Therefore, let's say you put your maximum number here as 5. So we're going to count starting from 1. And then now, while that number is less or equals to the maximum number, while we have not reached the limit that we've passed here, we can now yield that count. And then I would explain this one. Like take some time before now yielding another one. So for example, here, we can now say for every number in count of 5, print that number. Let me show how this one is happening. And this is actually how generators work. So instead of just returning information, it yields information in a synchronous fashion. Okay? I think someone has found for us a definition. Maybe you can go to the chat. Alfred, thank you. I think, Alfred, you've researched in context of AI, you'll be told that a generator typically refers to a model or an algorithm that generates new contents like image, text, or patterns learned from existing data. So that, I think that is in the idea of AI, but you can research it in the idea of Python and research it in the idea of Python. It is mainly used when you are trying to render information in a certain synchronous fashion. So instead of now using return, we can use yield instead of return. So I think a good example I've shown you here is when we are counting, we can now generate yield information at a given duration. So in reality, is when we are generating information back to the user. Yeah, sorry for that one. So, yes, so in terms of Python, thank you there, Alfred. Now, a generator is a special type of a function that can be used to generate information in a certain sequence rather than computing, rather than now computing them at once. So instead of just presenting everything to the user, we can now generate them in a certain sequence. And this can be done using a yield function. And this is something you've seen, especially in a lot of AI application. Like, for example, you have a response like this one here. AI engineering is a fun and profitable career to try on. So if you are using generators, then information are not just being popped everything there. We now generate them in a sequence. As AI is getting information, we are yielding them back to the user. So to explain this logic, I have a function here called stream LLM response. So for this function, you're going to give it a text, then it will simulate how a large language model generate its responses, okay? So for every token, in this text, as we split it, so remember the text that you pass here, we are going to split it here. And then we are going to split it into tokens. And now this token that we've split, we are going to yield them. Take some time before yielding another token, okay? Yeah, so we can now print AI response, this part here. So this part here, after seeing this part here can be done using this one, where n represents that we are now doing it in a line, in line. So we can now say that every word in LLM response, for every word here, we'll be yielding them at a time. And that's what we are getting here. And this is actually a practical example of how a large language model provides their everything out So remember, if you didn't have a generator, then we could just provide all the information at once, which is not practical. The best way to do it is to sleep before yielding information. I think if you give it like 4 seconds, 0.4 seconds, it's good there. So AI engineering is fun and profitable. You can even try to reduce time to, let's say, 0.3. Sorry. I can say 0.3. So now we are not allowing the AI to provide everything to the user. So the user will not know where the response started, where the response ended. So we can be generating them in a certain manner that we are now calling a generator. And if you've checked the definition from Alfred, it is a way to generate sequence of values step by step in a certain sequence rather than now computing them. It will be very, very applicable, especially now when we are now talking about responding the responses back to the user. Any question with generators? So remember, if you want to know you're using a generator, most of the time you're going to see the yield keyword. So if you see the yield keyword in Python, then this is a generator in such a way that information that are being yielded in a certain sequence. Okay, in a certain sequence. Anyone with a question with generators? Anyone? Yeah, so what is the symbol used in generators? For generators, we don't have any symbol. We just have this keyword called yield. This one here, called yield. This one. I hope you're seeing that one, Alfred. This one here. And this keyword that we're now referring to as a generator, it's able to yield information in a certain sequence, rather than now computing everything at once. And that is very, very applicable, especially when these AI models are giving responses back to the user. I hope you're together up to there. I can see you're together there, Alfred. Another question with generators and decorators. Finally, we can talk about data validation using something called Pydantic. Okay, so I was trying to be more realistic with the examples I'm using, but Pydantic is very key, especially when you're trying to validate the information that are being generated to the user. So a good validation that can be done is when you want to check a data type. When you want to check a data type, okay? So let's see what Pydantic solves. So let's say you want to enter a club where you have a bouncer. So one thing the bouncer will ask you is for your age. Remember, your age must be a number. And then the application returns your age plus 0. I hope you can see that one. So give me your age, it returns your age plus 0. Let me run this application so that it makes sense what I'm trying to explain. If I run it here, I don't know whether I can input this one. Yes, I can input it. Let me just input here so that it looks better. Enter age. Let me just input here. So enter your age. Perfect. That's that. So if I run it here, enter your age. I can enter my age. Let's say I'm 45 years. I think there's a typo error. I know where it's coming from. Let me just return it the way it was. Sorry, that one. Yeah. So you want to enter the club, you need to provide your age. Let's say I am like 15 years. So the application will return my age is 15 because I've taken my age, I've added 0. But remember, there are those users who want to try out things. What if I write my age in words? Instead of number, I write it in words. So remember, you cannot add a word to 0. Your app will crash. Let me show you what I mean here. Instead of saying my age is 15, I might say my age is something like 20. Let's say my age is 20. So what the application is trying to do here, it is trying to take that 20, add it to 0. So remember, there is a mismatch. You cannot add a string and an integer. That would not work. And that's why your application is crashing. I hope you can see. And the crash, the error you're getting, there is a typo error. This typo error means that we are trying to add your age that you specified is 20 with 0. So there is a type. You should not always get such kind of errors. In other words, this is sometimes called exception handling. Errors that are caused by users. This error was caused because instead of the user writing its age in number, it's writing the age in text. And that's why you're getting that error. So this error can be solved using now what we call data validation using Pydantic. And that's what you are being told here, that Pydantic prevents this crash before it happens. What do you mean here? It means that if you have the knowledge of Pydantic Python, you are able to figure out the type of data that we are expecting and handle it before we get an error. Let me show you how this one can be done. Yeah, so we can now say from a library called Pydantic, we can import the base model and we can import a class called validation error. So remember, these are classes. If you've done OP, these are classes. Just like we said, classes start with capital. So there is a class called user, and this class inherits the base model of our Pydantic. So remember, we've been talking about inheritance. So this class called user inherits the base model. And this base model allows us to specify our data types, whereby you are telling the system that for every user having a property of username and age, the username must always be a string. So this is very possible with the use of the base model, and then the age is an integer. So we can provide something called the strict rule, okay, to now prevent such crashes you are seeing here. So we want to do that. We want to prevent that one from happening. Now, using exception handling, we can now pass this operation here. We can pass this operation here, okay? And now, in case there is an error, we can now raise except. So remember, Python uses the keyword except. In other words, exception handling, it's a code that is in between that piece of code that you're trying to check, okay? Remember, we've said that the username must be a string, the age must be an integer. So we are checking that one here. In case the user makes that mistake, then we can now do exception. That is what we are saying, except. We can raise an exception that was a validation error. So the system will not crash and the user will know that probably the age should have been a number. So let's try to run this one here. This is working. This is working because the username is a string. The age is a string instead of an integer. That's why you're saying that the age must be a number. Let me give an example where we give it a number like 20. Say we give it a number like 20. then the system works. I think we can print something here. Can print valid information. You can just say valid data. That one, yes. Instead of just not printing anything, you can say valid data. So these are valid data. In terms of our valid data, the rules are the username must be a string. The age must be an integer. So if a user passes the information here that we defined using the base model, then we are good to go. But in any case, a user makes a mistake, we are not going to crash that application, but raise an error telling the user where the problem is. So if you run this one, that is a valid data. What if you say your username is 10? You say username is 10. That is not a valid data because I think we should have said, we should have checked for both the username and the age, okay? So all the time you're checking whether users are passing the right information. And this is sometimes called now exception handling. We are trying to handle errors that are being caused by the user's end. And this can be done using data validation. And this data validation that we are raising here is being implemented using Python Pydantic module. So in reality, coming back to reality, why we need to do data validation, we want to integrate our applications with other applications. Okay, remember, let's say you want to integrate your AI with your company system, or you want to integrate your AI model with your school system or your insurance system. So remember, for these two systems to communicate, the data type must always be in form of JSON. I don't know if they're seeing that one there, JSON. So your data must be in form of JSON. So I think in full is called JavaScript object notation. And this is something you're going to see, especially when you're working with APIs. Okay? So if you have one system communicating with another system, they have to agree on the standard format of data that they can communicate with. And the best format for that one is JSON. So with Pydantic, we are able to guarantee that our outputs are in form of JSON so that now they can be used by other systems. So I don't know whether someone is willing to research for us what is JSON data. What is JSON data? Someone maybe can research for us what is JSON data and why is it used whenever two applications are communicating. So remember, we are learning this AI so that we can integrate this AI application to existing system in banking, existing system in healthcare, education, agriculture, energy. Therefore, our AI model must be able to communicate with those existing systems. And therefore, they have to agree on a standard format of data that we call JSON. Thank you, Alfred. Alfred, you're saying that, thank you, that you're saying that a JSON, in full, it's called JavaScript Object Notation. It's a data exchange format that is easy for human to read and write and easy for machine to parse and generate. So in simple terms, thank you there, Alfred, a JSON data is a data format used for data interchange. I don't know if it's making sense. An AI model has provided a response. That response, you want to integrate it company website or company application. So our AI model should release information in form of JSON so that JSON data can be used by another application. And that's what we need. I'm now able to communicate. So Alex, thank you. They're also saying that it's a lightweight data format used to store and exchange data between systems. This system could be between browser and server. So if you say browser and server is backend and frontend, between one system and another one. For example, you find e-commerce system communicating with M-Pesa systems. A good example, you're able to make some payments in Jumia. Jumia is communicating with M-Pesa because they have a data exchange format in form of JSON. Initially, systems were using XML, but nowadays we use JSON out. I think it's something you're going to see as we are now building this AI application. Yes, JSON. Yeah, JSON is data exchange format. That is the best definition you can define JSON. Is a data and exchange information. And we need to that will be used by other people. Okay, let's say you're in insurance sector. So the responses that your AI is producing should be now be used to the people in insurance. So those responses must be presented to those applications. And therefore, we need a data exchange format that we are calling JSON. Yeah. How does JSON look like? If you check my browser, they look in this way. They are normally dictionaries. So JSON are not that complicated. They're just dictionaries. If you've understood Python dictionary, then that is also a JSON. And this JSON data can be used by other applications. It is in one application and another one. So right now we are learning Pydantic because form of JSON. And this output can be now integrated to other applications and now people are able to use these AI products. It means that now we've come to an end of should be now transitioning into prompt engineering principles. It's a very important idea in AI because we are going to learn how to effectively use these models. You write the best prompt so that you get the best responses. Okay. So I think I'll share with you the assignment on the group. I know this one, but I just wanted you to write a research, not a coding assignment, but a research assignment on object-oriented programming principles. So maybe you can just go try to research on your own understanding what is those principles. They're here. Yes, these principles of OOP, like what do you understand by inheritance? What do you understand by encapsulation? What is polymorphism and what is abstraction? So later tomorrow during the day, I'm going to share with you an assignment that you can do, just trying to test your understanding on this concept as we now introduce prompt engineering principles tomorrow. Anyone with a question? like we had agreed, PM. So I'm going to give you the 2 minutes. If you have a question, feel free to ask, and then I'm going to respond. So if you don't have any question, you're free to leave. Then we meet tomorrow. Anyone with a question can ask it right now up to 8:30. Yes, there is a concern I should share the notebook. Yes, I'm going to share the notebook and also the recorded session for this class. Yes, I'm going to share that one as well. Anyone with a question, you can pass it here, or a concern. Be creating your LeetCode accounts and start exploring how LeetCode is very, very useful in doing the practices. So you can either work with LeetCode and also HackerRank. But for now, I highly recommend LeetCode. Then you put should be signing in. Yeah, you're welcome, Alfred. Yeah, so this is actually one of the best websites that have built a lot of experts. Someone cannot be an expert overnight. For you, and I think the best website that most people have used here. There are problems here. The problems that you have depends with the topic you are having. Like for my case, I've done a lot of problems in data, but most of these problems you're going to find that most of them focuses on data structures. So most of them focuses a lot on data structures. I can guarantee you that if you've completed the first 20 tasks, you should be an expert here. And the best thing is that now we have AI. So you can even use AI to explain to you how to start. And then at some point, you try it on your own until now you become an expert. I think there is a concern with yes, recap sessions will be there. I'm not sure whether we have it that from February we should be having physical online and physical from February. But I think for this Saturday, I'm not guaranteeing that we. I hope I've answered you, Kim. Yeah, so this is the best website that you can try right now. Depends with now the topic you want. Binary search database and so on and so forth. Yeah. Did I get my? I think my questions. The most of the interview I've done here is on data science. And so on and so forth. And then there's also another one called HackerRank, very, very good. You can also try it out. And this is where a lot of developers are made because development is made by practices, routine practices. So no more questions. Let's stop there for today. I'm going to share with you the research assignment on object-oriented programming. Then tomorrow we'll proceed with prompt engineering. So have a good night and bye-bye.